On December 19, 1944, while the outcome of the Second World War still hung in the balance, American machine gunners operating across three massive combat theaters, Europe, the Pacific, and the Mediterranean, quietly completed and submitted more than 47,000 after-action reports, routine documents meant to track ammunition usage, weapon performance, and maintenance issues. Yet taken together, these reports formed the most comprehensive real-world weapons reliability dataset in military history. One that would quietly obliterate 60 years of unquestioned engineering doctrine, because the aggregated numbers revealed something no ordnance board, weapons laboratory, or procurement committee had been willing to admit. Gas-operated machine guns, long celebrated as the pinnacle of modern automatic weapon design, suffered stoppage rates exceeding 34% under sustained combat conditions. While John Moses Browning's recoil-operated machine guns, dismissed for decades as crude, antiquated, and mechanically unsound, recorded an average stoppage rate of just 3.2% despite using identical ammunition, operated by the same soldiers, exposed to the same environments, and fired in the same battles, with the only difference being how each weapon harnessed the energy generated by firing. A difference rooted in a moment in 1900 when Browning entered the U.S. Ordnance Department carrying a prototype that violated everything the assembled experts believed about automatic weapons. Because instead of siphoning off expanding gases through narrow ports and tubes to drive pistons and operating rods, Browning allowed the barrel itself to move rearward under recoil, using that violent motion to unlock the bolt, eject the spent cartridge, and chamber the next round before heavy springs forced the system back into battery, a design so simple that it appeared almost naive, and so contrary to European precedent that procurement officers immediately labeled it mechanically unsound. Citing concerns about barrel alignment, accelerated wear, increased mass, and reduced accuracy, while insisting that gas operation, refined since Hiram Maxim's work in the late 19th century, represented the sophisticated modern standard for automatic fire, a belief reinforced by decades of peacetime testing, elegant engineering theory, and the institutional comfort of consensus. And so for the next 40 years Browning's recoil-operated designs were tolerated but never fully trusted. Produced alongside gas-operated weapons but consistently framed as heavier, cruder, and less refined, until the war forced theory into direct confrontation with physics under conditions no proving ground could replicate, from the frozen fog of the Aleutian Islands to the suffocating humidity of the Pacific jungles and the oxygen-starved cold of bomber formations flying at 25,000 feet over Europe. Environments that transformed engineering elegance into liability and exposed a fundamental truth that laboratory tests had concealed. Complex systems fail where simple systems endure, a lesson first written in ice on Attu Island in May of 1943, where American soldiers assaulted entrenched Japanese positions through fog so thick visibility dropped to 100 feet, with temperatures below freezing, wind howling across tundra that sucked at boots and drained strength with every step, and where squads carried a mix of M1 Garands, gas-operated Browning automatic rifles, and recoil-operated M1919 Brownings, only to discover within 72 hours that moisture condensed inside the bar's narrow gas tube froze solid, blocking gas flow and turning automatic rifles into single-shot weapons at the exact moment sustained fire was needed to repel counterattacks, while the heavier M1919s continued firing uninterrupted because their recoil systems generated violent, full-stroke mechanical movement that shattered ice, expelled moisture, and overpowered thickened lubricants. A disparity recorded in maintenance logs showing nearly half of issued bars deadlined while recoil-operated guns experienced almost no failures, forcing squad leaders to advance uphill with frozen weapons against enemies whose machine guns never stopped firing, a reality so stark that commanders quietly reordered weapon distribution despite Washington dismissing the findings as isolated Arctic anomalies. A dismissal that collapsed entirely once the Pacific Theater delivered its own verdict. Because island warfare exposed weapons to relentless heat, humidity, rain, and corrosive salt air that infiltrated every seam and crevice, turning gas tubes into rust-filled choke points within days, while recoil-operated machine guns with massive bolts, heavy springs, and generous tolerances continued cycling through fouling that would have disabled more delicate systems, a difference documented during the New Georgia campaign where over 96% of M1919s remained operational after nearly 2 weeks of continuous combat compared to barely 61% of bars, with failures overwhelmingly traced to gas system corrosion, carbon buildup, and short-stroking. Findings reinforced by meticulous records kept by soldiers who had learned through loss that weapon. Reliability was not an abstract engineering debate, but the dividing line between survival and death. Men who observed that gas-operated systems demanded constant cleaning to keep narrow passages clear, while recoil-operated systems expelled fouling through brute mechanical force. A truth that forced the Marine Corps to quietly prioritize recoil-operated cruise-served weapons for jungle warfare, even as official language avoided admitting that 6 decades of consensus had been wrong, a realization that echoed thousands of feet above Europe, where Browning's recoil system reached its most extreme expression in the M2.50 caliber machine gun, a weapon dismissed by critics as overbuilt and outdated yet tasked with defending B-17 bombers in conditions that defeated nearly every alternative, because at altitudes where temperatures dropped to 40 below zero and sustained fire overheated gas systems. The M2 continued cycling, shaking carbon loose through violent barrel movement and maintaining function through long bursts that kept German fighters at bay, a reliability reflected in Luftwaffe intelligence reports noting that American bombers sustained defensive fire longer than expected, a mystery explained not by superior courage or training but by mechanical simplicity, as M2s recorded stoppage rates barely above 2% during sustained high-altitude combat. A pattern repeated on the ground where critics pointed to the German MG-42's blistering cyclic rate as evidence that Browning's slower-firing guns were obsolete, ignoring the reality that such rates imposed crushing demands on ammunition supply, barrel replacement, and maintenance that proved unsustainable under prolonged combat, a reality finally quantified when the U.S. Army compiled 94,000 after-action reports in June of 1945 in the largest automatic weapons study ever conducted. A study designed to settle decades of debate by measuring stoppage rates, maintenance intervals, and operational lifespan across all theaters, and whose conclusions were unmistakable. Recoil-operated machine guns recorded far lower stoppage rates, required significantly less maintenance, tolerated fouling and wear better, and remained operational far longer than gas-operated designs, with M1919s averaging nearly 100,000 rounds before major component replacement compared to roughly 42,000 for bars and even less for high-rate gas-operated systems, data that forced the Ordnance Department to formally recommend recoil operation as the primary design principle for future cruise-served weapons, a reversal so complete that it vindicated Browning decades after his death. As the numbers revealed that between 1941 and 1945 American factories produced nearly 2.5 million recoil-operated machine guns that fired more than 12 billion rounds in combat with an overall stoppage rate of just 3.2%, a figure unmatched by any contemporary system and sufficient to keep Browning's M2 in continuous service for more than a century, while every gas-operated design of its era was eventually retired, proving that Browning's genius lay not in complexity but in clarity, in recognizing that every gun generates violent recoil energy and that the most reliable weapon was not one that tried to tame or redirect that force through delicate mechanisms, but one that embraced it fully, letting Newton's third law power the gun itself, a principle dismissed in 1900 as crude and mechanically unsound and proven in war to be mechanically inevitable, because when everything else failed, training, planning, logistics, leadership, the simplest mechanism kept firing, and that alone decided who lived and who did not.